the libraries. And as you can see, I have pandas, numpy, matplotlib, and then seaborn. Let's get into it. Here we are handling the missing values. As you can see, we are handling the missing values with mean, median, mode, or we can even use advanced techniques such as predictive modeling. And underneath this, we have few other things. What we do, we try to load the dataset first. So it might be in your own path, and then use that to load the dataset, and after which we are trying to fill in and show the missing values. So here we use the seaborn library which we just imported, and we give it a label, title, then we show it. As you can see over here, we have the x-axis and y-axis. And the x-axis we have these columns, and each of them are showing up as not empty. And finally, after that, we explore our data. Here we see the head, and then we do the info. We do the description. So what the head shows is these few records, maybe like 5 records, and after that we see the info. Here we see the values, and then we have the description. We have the non-null count, and then the type here, as you can see, it's an integer for passenger count, which will be our predicted column. And if we go up, we see it's for description. So df.describe. Now we are going to handle missing values. And now, as you can see, we have the is null, and then we do a sum to see the missing values, and it's showing up as 0. And finally, we have the fill na value filling function, and we use in place true, and then we fill the passenger count. And df.drop na, what it essentially does is it will drop any of those which are having missing values, and then we use data transformation. And for that we use the get dummies. And as you can see, we have arrival, departure, and we split that into 2 columns as shown here, as depicted by false and then by true. And as we go down, we can see that it is filling it out, and we also do standard scaling as shown above. So that does it for the other fields, like you see for passenger count. And this is what is currently the output. Now we do the outlier detection. So in order to remove any outliers in the data, we use this boxplot, and we use the SciPy library. And as you can see, we do it on the passenger count, which is shown over here, which is already scaled. And the same, if you go up, we already did standard scaling, and we also did a fit transform, so that it's already scaled for us to do the outliers. And as you can see, these many outliers are present, but this is the quartiles, first, second, and third quartile, and it doesn't feel too much of an outlier as shown over here, so we should be good. Now we are going to do feature engineering, and there are some columns like the data extract date, and as you can go up, it is like a timestamp column. And what we see is we convert those into date, month, and year, and we use those specific columns, and we extract date, month, and year as accordingly. And we also convert this one to the AM and PM. So we get the data extract date, and we make it into either it's in the morning or in the evening, in the first half or second half of the day. And then we also drop some unwanted columns, and also including the data extract date. So as you can see, we have the values, the date, month, year, and if it's AM or PM as needed. And the data extract date and report period is gone. We have terminal, domestic terminal, and the final AM, PM columns. Once we go down, we have the categorical encoding. So we have these 3 ways, usually label encoding, on-hot encoding, ordinal encoding. So as we go down, we try to do the label encoder for the terminal. So we make a column called terminal encoded, which is based on the terminal, and then we use one-hot encoding for the domestic international, this column, and we do in place. And also we map it to AM as 0 and PM as 1. So as you can see, the output shown in the table below is for the encoding. And if you scroll down to the right, you see the terminal encoded, and to the left you see the terminal encoded. Over here we can see the terminals T1 and others, right? So those were converted to 2. So what I'm trying to show you is, if it is 5, it is now changed to 6. So it starts at 0, right? So that's why it is like that. So if you go down, we have the data visualization. So here we are trying to do is, we are trying to see the scatter plot and the heat map to see what is the correlation. So we are going to visualize the data, as you can see, with the passenger count, and we are trying to do the heat map. So first let's do the histogram, and you can see the values which are shown for the histogram. So based on the axis that we have given, we are able to visualize some data. Now let's try it for the scatter plot. So if you do a scatter plot, it shows up like this, but it's not giving meaningful data. But we can tune it. But until then, let's see the correlation matrix. So here, as you can see, we can get the most useful information. The passenger count and other columns over here, and the others same over here on the y-axis and x-axis. And whatever are related to each other or the same, you have the high correlation as shown by the numbers. So the darker it is the correlation is higher, and the lighter towards the blue, it is lower in correlation. So finally, after you see and select and know what to do, we are saving it as the cleaned data and with a name.